Thank you very much. So, hello to everyone. Football coaches say that half of the information that they need is position, and the other half is orientation. For example, in the starting of this presentation, the actual model said that I was on the stage correctly in place. So, actual model said that I was fine, but as you could check, I wasn't. So, orientation. In football matches, just the orientation determines if the ball reaches the goal. For example, in the left side, you can see Messi is well oriented and he can pass the ball. On the other side, in the right side, just with the orientation, the pass must be bad. A couple of years ago, one video was popular that appears Pep Guardiola and Sterling in a training, and the video was the following. We can see Pep Guardiola and explaining something to Sterling, and what he's explaining is the body orientation in a match. So here, he is very strong in explaining. So yeah, body orientation. Body orientation is key in a football match because on one hand, for example, in probability pass models, if you have body orientation, you know where you can pass the ball. On the other hand, for example, if you are a defender and attacking is going to you, if you are bad oriented, the attacker will surpass you easily. This body orientation can be taught and learned in training. And also, body orientation is not computed yet, and is a major subject in football analysis. The videos that we had in order to get the body orientation is panoramic videos, which has a fixed camera, which is not rotating, which will be useful. In this project, we had a play between both teams from Football Club Barcelona. We recorded it in a panoramic video. And this is an example of it. So on the other part of body orientation, we can get it from wearable tracking units, which are the one that also the players were using. In the video, you can see the green arrow is the orientation, and the blue one is the velocity vector. They don't always correspond. But wearable tracking units have several issues. For example, the opponent's team, you don't have the orientation because they don't want to share with you. And already played a match, you don't have the orientation if the players didn't wear this unit. And the professional teams doesn't like to wear these units. So we try to do a non-invasive method to get the orientation. So the first part of the method was training a model. We had two ways, training from panoramic videos, but the data is very few. So we decided to create a synthetic model with Blender, which is this software, popular software. So we create a player that looks like a football one from Football Barcelona. But this player was static, so we had to animate it also with Blender. We use 3 motions, walking, running, and kicking the ball. And with these 3 motions, we generate 30,000 pictures, 10,000 from each motion. We randomly chose the number of the t-shirt, the position, the orientation, and the frame of the animation, and we generate 30,000 pictures. One example of walking are these pictures, running, and kicking the ball. From this step, we wanted to check how realistic was the synthetic model. So we place our players here. As you can see, there are 20 players from FC Barcelona, which some one are real and the other are fake ones. So we gave it to our coaches in order to check if they can distinguish which are real or which are fake. So these ones are the fake ones. I don't know if you guessed it right. I hope so. So once we have the picture, we want now that it looks like the one that we are getting from a panoramic video. So it has 500 times 500 pixels. We have to do a downsampling. Then we had a football pitch background we added, and we did a little bit of learning. So with these pictures, we have 30,000 pictures. We want to train our model. Now we have also two ways to do it. One way was training a neural network, and the other way was using a software which was OpenPose, which is this one. We use OpenPose because it abstracts of what looks like the player, so we can predict opponent's orientation. Because OpenPose gives us the pose 2D pose of each player in the picture, and not only it draws, also in pixel space. As you can check, OpenPose detects all people, more or less. So we pass it OpenPose to our pictures to our pose, OpenPose, and it detects this skeleton. Moreover, we compute some triangles, the area from triangles, useful for detecting the orientation. And that's all, and we train our model. So now we want to predict from a video that we haven't seen. So we have the panoramic video and the location. It's compulsory to have it. And then we crop the players. For example, we use Metrica, and they give us this position of the players, and we crop them. We pass also OpenPose, and we compute these features as we did in the training part. Now we have a problem because we are just detecting one frame at a time. But as the video is already stored, you can know what happened before and after the frame. So we want to have a stronger orientation. So what we did from a sliding window of 9 frames, first of all, we can place easily orientation over a circle, and we make 2 groups. We discard the group that has fewer orientations. And also, we used a normal distribution in order to have weight to each frame. We're considering this frame, and as it goes further, the weight is less. So now, this is how we compute the orientation, and we want to check it, how good was it, or how bad. So first of all, this panoramic video was recorded, well, this match was recorded in panoramic video. And on the other hand, they were wearing a wearable tracking unit, which is called WIMU. It has a 3D magnetometer, which gives us the real orientation of the player. So we did 2 validations, numerical and Visval. From numerical, it has matrix and plots. Visval, it has the video. So in order to do this comparison, from the 22 players, we chose 6. 2 center fullbacks, 2 midfielders, and 2 attackers, 1 from each team. So here you have, in green, the real orientation. The yellow is our orientation computed with temporal fusion. And just showing the 6 players that we chose. The numerical one, it will be fast. You have here in the y-axis the real orientation with 36 groups, making each group 10 degrees. As you can see, the diagonal is pretty strong, pretty high. This is without temporal fusions. As the resolution is very low, sometimes the open pose fails and the orientation is really, really bad. So making the pass to the temporal fusion, it goes from 3,000 to 10,000. And also the orientation, the diagonal is very, very strong. Here you have some plots, very, very fast. The dotted one is the one from WIMU, and this one is the one from our orientation. What means these plots? It means how many meters they run going forwards. As we have the orientation speed, we know if the player goes forward, sideways, or backwards. So we did these three plots. As you can see, are pretty much the same. This one is from the center fullback. We also did from all players. For example, this is the midfielder from Team A. And I want to show you this 4K video from the first team. It's computing the orientation of the 20 players. So here you have seen every player. I think it's pretty fine. So what applications can have the body orientation? For example, in training sessions, you can have the training load. So if you have the orientation, you know if the player is moving forward, sideways, or backwards, and the articulations and muscles that are affecting in this run is very different. So the orientation could improve the realism from the training loads. Also, for example, the major benefit is when integrating the orientation with positional data and event data. For example, it could improve the ball loss because the orientation can be checked when the player lost the ball and say if it was right or wrong. On the other hand, for example, in a ball control, the orientation helps to detect a better path towards the opponent. If you receive the ball and you were facing in another way around, you could make closer to the opponent's goal. So another thing, another application of the body orientation is, for example, pass probability. It could improve in two ways. The first way is that the player that has the ball can pass everywhere, as it can now. It just can pass where he's looking at, or if it's backward with the heel or something like that. On the other hand, we have the receiver body orientation. If we have this receiver body orientation, if the receiver is not looking at the passer, then the pass must be a through ball, and if he's looking at the passer, it must be a direct pass, for example. Also, another model that could be improved is this model that you are watching, which is a pitch control model. In this model, we are only considering the velocity vector. If we had the orientation on top of that, the area will be very different. In case that the player is not looking where he's running. This is a goal from Coutinho. So I want to show you a video from Ronaldinho, which made incredible passes, and the orientation, it's not on.
Sei que me observam. Sei que todos os olhares me seguem. Milhões se ligam no show. Todas as semanas, 100.000 pessoas esperam o inesperado. A imprensa analisa cada movimento que faço. As defesas analisam minhas jogadas. Sei que todos os olhares me seguem. Seguem meu número, segue meus pés. E aí, o que você faz quando todo mundo te olha?
That pass is incredible.
Você faz eles olharem para o outro lado.
And at last, I want to thank you that this department, the analysis department from FC Barcelona, that has helped me a lot in this project. So thank you to all. And questions. So thank you for your attention.